So we're going to look at some more identities today. Before we do that, we're going to have to review something called the Pythagorean identities. Alright, if you remember last class, we started with some reciprocal identities that you knew. These are also identities that you just have to know. Now, where do they come from? Well, if we look at the Cartesian plane, for example, and make this triangle, right? Whenever there's a triangle, you can use Pythagoras. So this is x and this is y, but you know that x and y are sine and cos. So in this case, x squared plus y squared is 1 squared, but x is cosine and y is sine. So that's where this one comes from. Okay, you don't need to know where you don't need to draw that out every time. You just know that that's one that we have learned. Okay, and then where does the next one come from? Well, if you were to divide by cos squared, sine over cos would give you tan, cos over cos would give you 1, and 1 over cos would give you secant squared. Okay, so we have those. And then where do you get cotan squared plus 1? Well, if we were to divide everything by sine squared, then you would get this one. Okay, so those are three identities that I hope that we're going to memorize. I believe they're on your formula sheet. But from them, there's one more that you need to know. Alright, if we take a look at sine squared plus cos squared equals 1, if I were to take away cos squared from both sides, sine squared equals 1 minus cos squared. This is another one that you should know. That's not on your formula sheet. And similarly, cos squared is 1 minus sine squared. That one is also one that you should know, because we're going to use them even today. Okay? So let's prove this identity. So I'm going to start by writing it out. Alright. Which side looks more complicated to you? Well, they kind of look similar, but my tip to you is that usually addition is more complicated than multiplication. So we're going to work on the left-hand side. Alright. Well, what are we going to... How in the world am I going to make this look like this? Okay, well, usually when we're stuck, we can go to change everything to sine and cos. So if we change this to cos over sine plus sine over cos, this gives us something to do. How do we add fractions? You're going to find common denominators. Common denominator would be sine cos. Like that. So what did we do to the first fraction to get that denominator? We multiplied by cos, so let's multiply the numerator by cos. Same thing here. What did we do to this denominator to get that? We multiplied by sine, so let's multiply the numerator by sine. And so this gives me cos squared plus sine squared over sine cos. Alright, and here's where we need to be good at recognizing what is this. This is one of the identities we learned today. It equals 1. So now you have 1 over sine cos. And what is 1 over sine? That's cosecant. What is 1 over cos? Secant. And there we have that proved. Okay. Let's try this one. Okay, so what's more complicated here? It should be pretty obvious that it's the right side. But what in the world are we going to do to make this look like that? Okay, well, right now it looks like there's not much we can do. Okay, but this should give you a little bit of a clue. Okay, cosecant is not, it doesn't fit here. We have cotan and we have cotan here on the left side. Somehow we need to get rid of that cosecant squared. And if you look, we have an identity for that. We have cotan squared minus 1 equals cosecant squared. Sorry, that's cotan squared plus. So let's substitute that in. You're going to get cotan, and then instead of cosecant squared, we're going to write cotan squared plus 1. And now it kind of takes care of itself. We'll multiply the cotan, so you get cotan cubed plus cotan minus cotan. Those cancel, and you have cotan cubed. Okay, let's try this one. Okay, so which one's more complicated? It's going to be the left side. And what are we going to do here? Well, we need to end up with cosecant. Alright, we have a cosecant there, which is multiplied by a cosine. And then we have a sine here. So maybe it makes sense to change the cosecant to sine, because then maybe I can put those two fractions together. So I'm going to go 1 over sine times cos squared plus sine. Okay, so then this becomes cos squared over sine plus sine. Now, how do we do this addition? We need a common denominator. We need to make this sine. Well, if we multiply the denominator by sine, you need to multiply the numerator by sine. Okay, and now if you look at the numerator, what's this equal? 1. So you have 1 over sine, which is equal to cosecant. Okay. Now, just a quick review. Remember I told you that generally we start by using some sort of an identity. So our first step here, we used that identity. Our second step, what did we do? We did an operation. And then your third step is, hey, you recognize where we want to get. Okay. So looking at this, I think the left-hand side is more complicated. The powers are greater. So what can we do with that? Well, I have a clue here. I want to end up with sort of half of that. It's not really half, but it kind of looks like it. Well, maybe you recognize that these are difference of squares. This is a perfect square, and so is this. Well, if they're difference of squares, that means we can factor. And how would you factor? You take the square root of both of them. And one is positive, one is negative. Now we want to end up with this, so what do we do with this? Do you recognize that's a 1? So that means we end up with just sine squared minus cos squared, which is finished. Okay. I'm going to stop there, let you try and do some identities, and then we'll continue with this example 2 in the next lesson.